Okay, so we already studied the parabola, and now we're going to study it a little bit more extensively. Not only will our parabolas open up or open down, they will now also open right or left. So they're getting a little bit more complex. And we're going to talk about them a little more specifically. So look at this definition. It says a parabola is the set of all points equidistant from a fixed line called the directrix, and a fixed point not on the line called the focus. Okay, so let's draw a picture of that. So here's a directrix. We'll call this the directrix. And we have a fixed point not on the line, not on the directrix, which we call the focus. So we've drawn our directrix, I've drawn the focus. The definition of a parabola is the set of all points equidistant to these two things. So the first point I can draw is the vertex. The vertex, if I were to draw a perpendicular line from the focus to the directrix, then on that perpendicular line, so right here is my perpendicular line, right? So right here is perpendicular line. Halfway in between that perpendicular line needs to lie my vertex. So right here is my vertex, which means this segment here is the same distance as this segment here, the same length. Okay, so let's check that out. What if I drew a point over here? I'm trying to eyeball this. That means my perpendicular distance from this point down needs to be the same distance as from that point to the focus. That looks pretty good. Let's draw another one out here. Okay, same distance here. These two distances need to be the same. Okay, that doesn't look very good. I think I need to shrink it in a little bit. Maybe more like there. That looks a little better to me. Right? That distance looks a little more accurate in the yellow. So this is the definition. Now these two look a little bit more the same length. Okay, so now we can create a box, right? We can go directly to the left, and then I can create a square instead of a rectangle. Okay, I didn't do a very good job. It has to be way out here a little bit further. So then I have a square right here. Okay, so then if I make my square over here, to me these are the two easiest points to make. The distance has to be the same from the focus as it is to the directrix, from the focus as it is to the directrix. So I make this square, right? Don't you think this is the easiest way to do it? This distance from here to here needs to be the same as here to here. I'm making a square. From here to here needs to be the same as here to here. I'm making a square. This was too far away, so I'm eyeballing it. So here are my points. I connect them, and there is my parabola based on the definition that I just read, which said it's the set of all points equidistant from the directrix and the focus. That's what that says. Okay, so let's look at the demonstration. It says let's check out the GeoSketchpad demonstration. So here it is. I have a focus right here. I have a directrix, which is this black line right here. I have a point. This point I measured from the focus to the point of the locus. So focus, point of locus, I get 3.10 inches. And I measured from the point to the drag point. Or sorry, the locus to the drag point, same distance. So I've proven that these two are the same distance. Watch, if we keep this distance the same all the time, what does that point create? If this distance between the focus and the point and the directrix stays the same, then it is creating a parabola, right? It doesn't matter where we are, continue, stop, those distances should always be the same. And what do we make? We make a parabola. So that is the definition. This is the picture that's kind of like on page 412, but you also must realize you can have a parabola go right or left. If I made my directrix here, the blue line is my directrix. I make a red dot as my focus. Then I can make the vertex halfway in between this perpendicular line, so I would call that my vertex, and then I would just make my parabola. This time my parabola has to open to the left. How do I know it has to open to the left? Well, because it can never cross the directrix, right? Notice that Geometry Sketchpad sample. Here's the directrix. The parabola will never cross the directrix. It always opens toward the focus. So the focus is in between or inside that parabola. This is the outside of the parabola. So the directrix is on the outside, the focus is on the inside. So here, when you see this is the focus, this is the directrix, I know my parabola is going to open to the left. Now my sketch is not very good, I would say. You're probably thinking the same thing. Because if I'm using that box method, here's this distance. If I went out and made a square, right, this other purple dot should be way out here. So my parabola should look more like this in this case. If I'm using this. Because remember, this distance has to be the same as this distance. From focus to directrix as focus to point on there. So I point to directrix as point to focus. Point to directrix as point to focus. So these 3 points, in my opinion, are going to be the easiest ones to graph and the easiest ones to find. Okay, so let's move on. It says, we will study parabolas that lie on the coordinate plane. As a result, we will make use of the distance formula to determine an equation for a parabola. So we're going to get it in vertex form like we saw in chapter 7. Well, what do they mean distance formula? Well, I just said that this distance from focus to directrix needs to be, the distance on a point to the directrix, a point on the parabola to the directrix and a point on the parabola to the focus, these distances need to be the same, right? Those distances need to be the same. So that is the distance formula. Find the distance between these 2 points, find the distance between these 2 points, set them equal to each other, and that is how you will get an equation of a parabola. Let's see what I'm talking about. Okay, the other thing is I like to graph. So example number 1. It says find an equation of a parabola having focus 1, 0 and having directrix y equals 3. Okay, so my directrix is y equals 3, so that's a horizontal line going through 3 on the y-axis. So this is my directrix. Okay, then I look at my focus. My focus is at 1, 0, so this is my focus. Now already I can see my parabola is going to open down, right? Because my directrix is above the focus, therefore my parabola will open down. The next thing I'm hoping that you will see right away is that if you drew a line perpendicular from the directrix from the focus to the directrix and intersected at 90 degrees, that halfway along that distance, so this distance is 3 units, halfway up is going to be my vertex. So I can actually get a point for my vertex, right? That should be pretty easy. I go to the right 1 unit and up half the distance of 3. So that's 1.5, 1.5, 3 halves. For the sake of having it in proper form, we're going to keep it as 3 halves. Okay, so this is my vertex. Now, why is this helping me? Well, it's not really helping me if we're going to use the distance formula, but I'm going to show you a way to not use your distance formula, and then you can decide what you like better. Okay, so my point. If I'm going to use the distance formula, I'm going to say that I need to have equal distance from any point on my directrix. Well, right here, what do I know about my directrix? I know that that point on the directrix, the x-coordinate can always change, but my y-coordinate will always be 3, right? In that GSP demonstration, you can see that point was always going along the directrix. We can't go off the directrix in order to find the distance. It's from the distance from the point on the parabola to the directrix. Well, the y-coordinate will always stay 3. The focus is a fixed point. The focus never changes. So the focus is what? It's 1, 0. And then we have our unknown point on our parabola. So the parabola point is x, y. That's my point on the parabola. So, okay, so now I need to find the distance between, right, according to that definition at the beginning, I need to find the distance between a point on the parabola and the directrix, and a point on the parabola and the focus. And we know the distance equation is the square root, right, of the difference of the x's squared plus the difference of the y squared. So that's what I'm going to calculate now. So the distance between the directrix and a point on the parabola. So I'm going to say x minus x, the quantity squared, plus y minus 3, the quantity squared. And then that must equal the distance between a point on the parabola and the focus. So this time I would have x minus 1, the quantity squared, plus y minus 0, the quantity squared. So hopefully you're thinking to simplify this, the first thing I would do would be to square both sides to get rid of those yucky radicals. So I square both sides, and then I'm going to simplify what's underneath. Well, x minus x is 0, 0 squared is 0. Here, I'm going to keep this as y minus 3 squared. And on the right-hand side, I'm going to, I'm trying to change colors. Sorry, on the right-hand side, I'm going to get x minus 1, the quantity squared, and then y minus 0 is just y, so I get y squared. Okay, now, we can't have an x squared and a y squared, but what would you notice would happen? Well, if I FOILed this out, this y squared is going to cancel with this y squared over here. So remember when I FOIL this out, I get y squared minus 6y plus 9, and on the right-hand side, I'm going to keep that x minus 1 squared, because remember, think about parabolic form, parabola form. What did it look like? You only have one squared quantity, not two. So here my y squareds will cancel. So I have negative 6y plus 9 equals x minus 1, the quantity squared. Now I need to factor out the GCF, or factor out my 6, because I need to get my y isolated. So if I factor out a 6, well, that means, what is this 9 going to become? I'm going to have to divide it by negative 6. And if I divide it by negative 6, I get y minus 3 halves. Okay, is this looking familiar? What do you notice? This is the x-coordinate of the vertex. This is the y-coordinate of the vertex. My last step is to move this over to the other side, because that's my letter A. So I divide each side by negative 6, divide this by negative 6. Well, there's an invisible 1 right there. So my final equation is y minus 3 halves equals negative 1/6 times x minus 1, the quantity squared. And that is the equation for this particular parabola. Or you could write y equals negative 1/6 times x minus 1 quantity squared plus 3 halves, depending on which form you wanted to write it in. But that's the answer. Okay, now, what do I think is way easier than this distance formula stuff? I think it's way easier, although I could be wrong and you may disagree with me, and that's okay. You don't have to do it my way or what I think is easiest. You do it the way that makes sense to you. Okay, remember up here I kept showing you to make this box, make this cube, or sorry, not cube, but a square, because these are all equally distant, and that's the definition. This must be the same distance as this. Well, that's what we can do here. If you can find your vertex, and we know this distance is 3 units, then you're going to go to the right 1, 2, 3 units, or to the left 1, 2, 3 units, right, and find a point on that parabola. So now, this is a point on the parabola. That point is negative 2, 0. Or this is a point on the parabola. That point is 1, 2, 3, 4, 4, 0. Okay, why does that help me find an equation? Well, you should know that when a parabola opens down, right, this is the formula for when a parabola opens down. So I'm still continuing with this problem above. So that was the equation we learned back in chapter 7. I fill in the blanks. What is k? K is 3 halves. What is a? We don't know. That's what I have to find out. What is h? H is 1. How do I find a? I find a by plugging in another point on the parabola. Oh, look at that. I have a point. It's negative 2, 0. So when y is 0, x is negative 2. Okay, look how easy this is. So I do negative 3 halves equals a times negative 3 squared. Negative 3 squared is 9. 9a equals negative 3 halves. Divide each side by 9. Negative 3 halves divided by 9. Well, that's the same as multiplying by 1/9. So a equals negative 1/6. Hey, that looks familiar. That's what we got there.